if I stretch it around this way along the x-axis? Well, that's my next graph, and that's just as crazy to think about. Now, oops, gone too far. This is my equation. This is my standard y equals x squared. There it is there. And this is my graph of, look at it carefully, y equals, open bracket, half of an x, and then square it. Have you got that? So not 2x all squared, but half of an x squared. So I can write it as y equals 0.5 of an x squared, or y equals, open bracket, half of an x, and then square it. Alright? Either way, I'm applying the same transformation. What is the rule? It says you divide the x coordinate by the a value. In this case it's going to be a half, but you leave the y coordinate unchanged. Let's see if it works. So here's my graph of y equals x squared. It's working black for now. I know it's y equals x squared. I know it's poking up in the air, but the graph software has given me a different scale. Look, when x equals 6, y equals 6 squared, which is 36. That's clearly y equals x squared. And that's the end of that one. And this is going to be the graph of y equals bracket half of x squared. And I hope my picture's not in the way of that equation there. That would be terrible. So what was the rule then? I take my x value and I divide it by 1/2. Okay then, let's see if this actually works. So this is my original y equals x squared graph, and let's apply this little arrangement. I'm going from 3,9 to 6,9. Okay, look at it very carefully. I've gone from 3,9 to 6,9. So what is the rule? You take the x coordinate and divide it by the a value. There's my little value of a there. So generic function then of y equals function of x, and then you come on and go y equals function of something times x. Alright, so I'm taking my y equals x squared, then I'm coming along and saying y equals, open bracket, half of your x, and then you can square it. And the rule is divide y by, so not y, what is it? Divide the x, wasn't it? Yeah, divide the x coordinate by the a value. Let's do that again, correct myself. So divide the x by a. In this case, divide by half. So e.g., 3 divided by a half is 6. Therefore, I've gone from 3, 9, not 3, 6. I've gone from 3, 9 to 6, 9. Remember, the y coordinate is unchanged. So 3, 9 to 6, 9. Okay. In the same way, I've got on this side, I've got minus 3 divided by a half is going to be minus 6. Therefore, I've gone from minus 3, 9, and that's become minus 6, 9. So if I draw that in with this function here, I'm going from minus 3, 9 to minus 6, 9 in that direction, and it's as though I've stretched out my graph. I've took my x squared and stretched it like that, as opposed to going I'm pushing it in. Alright, so that's what's happened. Right, that's about it then. Let's just reiterate quickly before I start losing my brain. Right, what is this? It's still a stretch in the x direction, but instead of going towards the y-axis in the positive direction, it's gone to the right hand side. So I think we call this, just go back and reiterate for myself now, this is a stretch of, in the x direction, scale factor of half, yes, from there to there. A stretch in the x direction by a scale factor of a third, yes, from 6 to 2. Therefore, this is going to be a stretch in the x direction of scale factor 2. I've gone from 3 to 6. Aha. Therefore, let's just conclude. It's a stretch, don't go glitchy, in the x direction by a scale factor of 2. And that is difficult, isn't it? Imagine you're dividing by a half, and so therefore you double the x value. So I'm going from 3 to 6. I've stretched it in the positive times 2 direction as opposed to in the half or third direction. It's still positive stretch because it's going that way along the x-axis. Alright, just like when you transform a shape by a scale factor of a half, it doesn't suddenly go into the shape doesn't suddenly flip over, it just becomes half the size. Here I've taken my 3 divided by a half, so I go from 3,9 to 6,9. So it's a stretch in the x direction using a scale factor of 2. And let's make that 2 look pretty, because that's really the conclusion to this matter. So what does y equals function of half x squared do? It stretches my y equals x squared in this direction. It pushes it outwards right off the scale here, and the only ones I can clearly see is where my minus 3,9 becomes a minus 6,9 and my 3,9 becomes a 6,9, and after that these go flying off the page like that, and off the video nobody can see anything. Alright, so quick reiteration on this very difficult rule. You divide the x value by the a, and in this case, for example, 6 divided by 2 makes 3, hence my 2x squared and my 3x squared. And if they're whole number values which are not fractions, then what's going to happen is it's going to push the graph, squidge it towards the y-axis, but I'm moving it parallel to the x-axis by squishing it that way. Well, not parallel, I'm just squashing it in the x direction, and that causes the branches of the graph to come nearer the y-axis. And this very difficult arrangement here, if I'm dividing by a number that isn't a whole number, a fraction like a half or a third, then it will stretch it in that direction, again along the x-axis, but it will be a scale factor of 2 if I'm dividing by a half, or a scale factor of 3 if I'm dividing by a third, or a scale factor of 4 if I'm dividing by a quarter. And there you go, really, really hard. Now the next time you see my face, I'll be doing real questions from the book, but it took 3 videos just to introduce these horrible things. Alright, that's where we're going to go next and apply all these little rules, and it's been really, really hard. Let's just flick back through the pages. Y equals f bracket ax. That's also y equals f bracket ax. This one is y equals f of minus x, a reflection in y. This is y equals minus f of x, a reflection in the x-axis. This is y equals af of x, stretch it in the y direction by multiplying the x coordinate by the a value, so these are vertical stretches. These are shifts to the left and right, moving it units to the right, hence 2, 0, units to the left, hence minus 2, 0. Left and right horizontal movements, not stretches or pulls or anything like that, left and right movement as described by vectors. And the last one, the easiest one, is moving up and down as described by vectors. For example, 0, 4, move it up 4 units, 0, minus 3, drop the whole graph down 3 units. So up and down movements, left and right movements, vertical stretches, horizontal stretches inwards, horizontal stretches outwards, and also the 2 reflections in the x-axis and in the y-axis. This is as A-star as it can get, and it's horrid. But there you go, you'll get some questions on this, and sometimes they can be really, really easy, and sometimes they can be really, really hard. Well, I've had enough of this, I really have, and I look forward to finishing this set of videos. It will be the hardest thing I've ever done, and I'll see you guys later.